Regular expressions, or regex in short, are a special way of writing patterns to search through text. Instead of looking for just one exact word, regex lets you describe a rule, like any 3 numbers in a row or any word that starts with a capital letter. With regex, you can find, filter, and check text based on the pattern you define. In Python, there are many ways you can write regex patterns, so let's just jump in and get started with some examples. The first thing we will want to do is import the RE package, Python's built-in library for working with regular expressions. But before we get started with the regex code, let's first cover the concept of raw strings. Python recognizes certain characters to have a special meaning. For example, \n in Python is used to indicate a new line. However, sometimes these codes that Python recognizes to have certain meanings appear in our strings, and we want to tell Python that a \n in our text is a literal \n rather than meaning a new line. This is known as a raw string. To indicate that our text is just a raw string and not a special character, we can use the R character before strings. R means raw and tells Python to treat backslashes and special characters exactly as they are, instead of giving them a special meaning. Let's see this in action by printing some text without using the raw string indicator. Suppose we want to specify a file path. We create a variable called myfolder and set it to c/desktop/notes. Notice that inside this text we have a \n. When we print it, Python interprets that \n as a new line character. So instead of showing the file path as we wrote it, the notes part is moved onto a new line. Now, if we add a lowercase r in front of our string and print it again, Python treats the \/ literally. This time, the file path is displayed correctly just as we typed it. That's why raw strings are important in regular expressions. They make sure special characters like backslashes are read exactly as they are. Now that we've covered raw strings, let's look at the first regex function, the re.search function. The search function checks whether a specified pattern appears within a string. It takes 2 arguments. First, the pattern to search for. Second, the string to search in. If the pattern is found, search returns a match object. If not, it returns none. When we print the result, we see a match object. Now let's try a case where the pattern isn't there. When we print it, the result is none, because the pattern doesn't exist in that string. Next, let's look at the re.sub function. The sub function lets you search for specific text within a string and replace it with new content. It requires 3 arguments. First, the text or expression you want to find. Second, the text that will take its place. Third, the string in which the search is performed. Let's try an example. Our string is, Sarah was able to help me find the items I needed quickly, but here the name is misspelled. It should be Sarah with an H in the end. So we can use re.sub to replace it with the correct version. In a new variable called newString, I type re.sub. The first argument is the incorrect version of Sarah, the text we want to find. The second argument is Sarah with an H at the end, the correct replacement. And the third argument is our original string. When we print a new string, the output shows the name written correctly, using our replacement. Now let's explore a bit more of the power of regex syntax. Suppose we have 6 different customer reviews about our staff. We want to pull out only the reviews that mention Sarah, but remember, sometimes her name is misspelled as Sarah without an H. To handle both cases, we can write a pattern with a question mark after the R. The question mark means the letter H is optional. So this single pattern will match both Sarah, with and without, and H at the end. Next, we create an empty list called Sarah's Reviews. Then we loop through each customer review. Inside the loop, we use re.search with our pattern. If the pattern is found in a review, we append that review to the list. Finally, when we print Sarah's reviews, we see that only the reviews mentioning either Sarah without the H or Sarah with the H are collected into one list. Now, let's try something different and look for reviews that start with the letter A. We again create a list for these new reviews. We use a raw string to define our pattern. The carré symbol tells us to look at the start of the string. So the pattern carré A matches any string that begins with the letter A. Once again, we create our for loop to go through the customer reviews. For each string in our customer reviews, if the RE search matches the pattern to find in the string, we take this string and append it to our A reviews list. Once we print this out, we can see that amazing work from Sardine has been correctly pulled for us. We can also search for reviews that end with certain letters. For example, let's find reviews that end with the letter Y. To do this, we use the $, which means end of the string. So our pattern is Y$, and it matches any string that finishes with the letter Y. Let's look at another useful regex operator, the pipe symbol. The pipe works like an OR. It lets us search for more than one word. First, let's create our empty list. The pattern to find here is open parenthesis, need, pipe, want, close parenthesis, ed. The parentheses are necessary here because they group the words need and want together. Without them, the OR would only apply to part of the pattern, and the result wouldn't work as we expect. So with this grouped pattern, we're telling Python, match either needed or wanted. Next, we loop through each customer review and add any matches to the list. Finally, when we print need-want reviews, we see only the reviews that contain either needed or wanted. Let's explore one of the most practical uses of regex, removing punctuation from text. This step is crucial in natural language processing because punctuation often gets in the way when we want to analyze words. Here's how we do it. We create a new empty list called no punctuation reviews. Then we define a pattern, raw string, open square bracket, caret symbol, \w, \s, close square bracket. Let's break that down. The square brackets define a set of characters we want to match. The carré at the beginning means not. /w stands for word characters like letters, numbers, and underscores. /s stands for whitespace characters like spaces. So together, the pattern means find anything that is not a word character and not a space. In other words, the punctuation. Now, let's use our pattern inside a loop. For each string in customer reviews, we create a new version of the review called no punctuation string. We do this with the re.sub function. The first argument is our pattern, anything that's not a word character or a space. The second argument is an empty string, which means we replace any punctuation we find with nothing, effectively removing it from the text. And the third argument is the text we want to clean, in this case, the current review from the loop. Each cleaned up review is then added to our no punctuation reviews list. When we print the no punctuation reviews list, we can see that all the punctuation has been removed. Regex offers many options, and it can take some practice to become comfortable with all its capabilities. But it's a handy tool for working with text, especially when you need to filter data or find pieces of text that match specific patterns.